Hello everyone and welcome to the Math Bender. I'm Adnan Zaidi and in this section we'll discuss linear law. This is precisely additional math topic or A-level P3 topic. Let's start. So before starting off, we need to have a few basic knowledge of how a linear equation is. So we know that y equals to mx plus c represents a straight line where m is the gradient and c is the y-intercept. Y-intercept is a point where the straight line cuts the y-axis. Gradient can also be represented as y2 minus y1 over x2 minus x1 or change in y over change in x. Now you see many equations like this: 2x plus 3, y equals to 3x, y equals to 7 minus 3x, y over 2 equals to x plus 4. All of these four equations that I've just noted down are linear equations. Now what you need to understand that here one variable y, one variable x. The last term or one term is without a variable. Here both the terms are there and the y-intercept is 0. Here one term is without a variable and here as well. This is all pretty much we need to move on. So let's see what a linear law is. If I ask you to draw y equals to x squared, so the first thing that you would want to look at is you make a box and in that you fill in some values. So if we plug in these values in the equation, I'll get these values straight away, writing those 0, 1, 4, 9. And if I draw this behavior on the x and y axis, I'll notice that, so taking these values, so at 0, 0, at 1, 1, 2, 2, and 3, 9. So if I draw this, it will be a curve like this, a quadratic curve. Now if I need to look at another perspective of it, let's take x squared is equals to t, and I can write the same equation as y equals to, which was initially x squared, now can be written as y equals to t. So let's draw this against t now. So now if I see x and t for the same values 0, 1, 2 and 3, the value of t will be 0, 1, 2 and 3. So let's draw this one. So I'll name my x-axis t for the moment and this is y. And if I plot the same values on the grid, on the same grid, I'll see that the behavior looks like a straight line. And if I draw that line, it will pass through 0, 0 and may look like this. Now notice that t was actually initially x squared, which I tempered, which I manipulated in a manner it looked like a straight line. So this is what linear law is about, converting or changing the x and y axis in such a manner that it looks like a straight line. So let's take some examples here. We'll see some of the questions here. Now, if you look at this first one, it says that y equals to ax squared plus b. And if I try to look at it, then our y is equals to mx, I'll take x as capital, plus c. Now, on the x-axis, if I take as x squared and y remains as y, as you could see, a turns out to be the gradient and b is the y-intercept. The same goes if we see another question, y equals to ax plus b over x. There can be many other solutions, by the way, to a question, so it depends how you take it. Now, if I multiply both sides by x, I will see that this is xy equals to ax squared plus b, and xy equals to ax squared plus b, where this is y, this is m, this is x plus c. So on the y-axis, if you take, instead of y, you take xy, and on the x-axis, if you take x squared, you will see a straight line behavior. Now, let's look at another question here. Y equals to a over x squared plus b. I'll give you both the perspectives. So straight away, if you see this, y is equals to a times 1 over x squared plus b. As you can see, this is y equals to, this is m, and on the x-axis, if you take it as 1 over x squared, it becomes linear. The same equation can also be written as, now if I multiply both sides with x squared, this will become, and x squared y is equals to bx squared plus a, and you can write this as y equals to m, this is x, and plus this is y-intercept. So on the x-axis, here the same equation on the x-axis was 1 over x squared, and on the y-axis was as y, but in this, the same equation, you can manipulate it in a different manner, and you get, on the y-axis you get x squared y, and on the x-axis it is x squared. Let's look at some more questions here. Now, y equals to 10 to the power ax plus b. Now, straight away, taking logarithms, log base 10, log y is equals to ax plus b. This is a continuation of log. You may want to watch previous logarithmic videos if you don't get to understand why I did that. So this is whole thing y, this is m, this is x, and this is the y-intercept, and it looks linear. One more question here. So x to the power of a, y to the power of b is equals to e squared. Now if I solve this one, I can apply log both sides, or I can apply ln both sides. It's up to you. So if I apply ln both sides, by the way, the idea of applying ln is by looking at e squared, but if you apply lg, that doesn't make any difference as well. So ln x to the power of a y to the power of b is equals to ln e squared, and you get ln x to the power of a plus ln y to the power of b is equals to 2. ln b ln y is equals to minus a ln x plus 2, and ln y is equals to minus a over b ln x plus 2 over b. Now look at this part. This thing is y-axis. This is the gradient, negative a over b. This is the x-axis, and 2 over b is c. Let's take another example. X a to the power of y equals to b. Now if I apply log both sides, or I apply ln both sides, it's up to you. As I said, let me apply log both sides. So x a to the power of y is equals to lgb. Note that this is just a constant. Now lgx plus lg a to the power of y is equals to lgb. lgx plus y lg a is equals to lgb. Now y lg a is equals to minus lgx plus lgb, and y equals to minus 1 over lga lgx plus lgb over lga. Now in this situation, as you could see, y-axis remains as y equals to, this is m, this is the x-axis where x-axis represents lgx, plus this is c. Let's move on to some already graphical representation where you have to find out. Now if you see this question here, as you could see that x to the power of 4 and y. Now the already tampered x and y axes are there. So rather than taking it x to the power 4, for the time being take it as capital X. So this coordinate is capital X and the y coordinate remains as y. And the same goes for the one. So first make the equation of the line. So your step 1 is, after seeing this, make the equation of the line. So the gradient m is equals to y2 minus y1 over x2 minus x1. In this case 3 minus 5 over 5 minus 1, which is going to be negative 2 over 4 or negative 1 over 2. So y minus y1, which is 5, is equals to negative 1 over 2 x, let's take this capital X, minus 1. 2 times y minus 5 is equals to negative capital X plus 1, and 2y minus 10 is equals to negative x plus 1. Since you have to find the equation, 2y is equals to negative x plus 1 plus 10, and y equals to negative x over 2 plus 11 over 2. Now replace x with its initial x with x's, which is x to the power of 4. So negative x to the power of 4 over 2 plus 11 over 2. This is the actual equation which was interpreted into a line by changing the x-axis. I'll solve another one. So if I see this question here, the gradient is m equals to, I'll directly find it out, negative 1, negative 3 over 4 minus 2, which gives you negative 4 over 2, which is negative 2. and y minus y1 is 3 equals to negative 2x minus 2, and y minus 3 is negative 2x minus plus 4. So x is taken as capital X. So y equals to negative 2x and plus 4 plus 3 plus 7. So y equals to negative 2. Instead of x, you write 2 to the power x plus 7. I want you to try solving this on your own, and if you need any assistance, you may write in comments. So here, let's take a look at this question. So first step is you find the gradient and the equation of a simple line. So m is going to be 15 minus 5 over 6 minus 1. So 10 over 5, which is going to be equals to 2. And y equals to 2x plus c. Taking 1 comma 5 as x and y coordinates. So 5 equals to 2 plus c, and c is equals to 3. Y equals to 2x plus 3. Now x-axis is as same as x-axis and y-axis is as same as y over x. So instead of y, you write y over x is equals to x-axis replaced with x plus 3, and the equation finally becomes 2x squared plus 3x, multiplying both sides with x. Let's take a graph question here. The table shows experimental values of the variable x and y. These are the values which are not proportionate, hence not making a straight line. And the variable are known as to be related with the equation that is given to you here. Now this question specifies what you have to apply and where. So first step, y equals to, I need to make a straight line and I need to have a linear equation. So y equals to LGY against x. So I am not supposed to draw x and y, but I have to draw LGY against x. So if I take these values into account, and so this is x, this is y. The values of x was 2, 4, 6, 8, and 10. The values of LGY, so we are not taking y, but we are taking LGY. So y was 12.8, 32.8, and 549.8. Now I am drawing against LGY, so which means on the y-axis it will not be y, it will be LGY. So let's find out the values of LGY. So now the values of LG (12.8) is 1.11. 32.8 So these are the values. So I have to plot these values on the graph paper. So I have these values to plot. So let's make a rough axis. So I have the maximum value that it reaches is 2.74. So if I take every value as 0.2, and on the x-axis I can take each unit to be this to be 2, 4, 6, 8 and 10. Now let's start plotting. So at 2 I have 1.11 somewhere here. At 1.5 at 4. At 6 I have 1.92. At 8 I have 2.33 somewhere here, and 10 is 2.74. Now the line that you have to make should be the line of the best fit. So the lines above, the points above the line should be as same as below the line. So if I join a line like this, this is fine. So if you want to make this equation of this line, then any 2 points apart from the values that are given. So if I take this point here, so this point here is 11, comma 2.8, 2.9, and this point here is 0, 0.7, or the y-intercept. The x-axis and the y-axis are LG. The x-axis is x and the y-axis is LGY. The equation of this line, now write these two coordinates, the one that we have taken down. So it's going to be 11, 2.9 and 0, 0.7. So y equals to mx plus c, and if you plug in these values in it, so m is going to be so equals to 1 over 5 or 0.2. You may take any. So y equals to 1 over 5 x plus 0.7. Y was LGY is equals to 0.2x plus 0.7. Now, you have to estimate the values of A and of B. There are two ways that you could do. Either convert this into linear and compare them, or convert this back to the other function. I'll show you both. So, y equals to a times b to the power of x, and if I apply LG both sides, it will become LGY is equals to LGA plus XLGB. And as you could see, if you compare these two, LGY is there. With x, there is 0.2 here, and here is 0 LGB. So the value of LGB is 0.2, and b is equals to 10 to the power 0.2. And the y-intercept is 0.7, and LGA is equals to 0.7, as you can compare them. A is equals to 10 to the power 0.7. One way of looking at it. The other way, if you now LGY can be written as y is equals to 10 to the power 0.2x plus 0.7. Taking the antilog, y equals to 10 to the power 0.2x dot 10 to the power 0.7. Now can you see that this is this, and b is, now to find out, 10 to the power 0.2 whole power x is equals to b to the power of x, and 10 to the power 0.2 turns out to be b. Was a pretty lengthy question though, but this is all you need to about linear law. I'll come up with some more past paper related questions related to linear law in my next lecture. Until then, take care. Bye.